the first homework question for this assignment. And it says balance the following reaction. And then it's small here, but I've written it a little larger here. I'm not sure if you can see it, but I wanted to make sure you could. Now, my method for balancing reactions is to place a 1 in front of the most complicated formula. And the most complicated formula has the most types of atoms, and it has the most atoms in general if there were a tie. But you can see there are 3 types of atoms in this first compound. So I've put a 1 coefficient in front of it. And then, according to, again, just following along with the lecture outlines, how to balance, go through and balance all the elements in this compound. And the one thing I'll say is, there's another rule that says balance 1 element formulas last. And the reason you balance 1 element formulas last is because whatever coefficient you put in front of the oxygens, it doesn't change any of the other elements, which is good because you want to make sure that in the end that everything stays balanced. So the process goes like this. 1 times 4 is the number of carbons on the reactant side. That means that since there's 1 carbon in carbon dioxide, and this carbon is the only carbon on the product side, I have to have a 4 coefficient. Now that means there's 4 carbons on the product side, and carbons are balanced. From there, I'm now going to balance my hydrogens. I have 1 times 8 hydrogens on the reactant side. Hydrogens come 2 at a time in H2O, and therefore I need 4 as my coefficient here. Now I have 8 hydrogens on my product side. And sure enough, I mean, oxygen was last in this formula anyway, but we were going to balance oxygen last. Now we count up the oxygens on our product side. I see 4 times 2, that's 8 oxygens, plus 4 here, that's a total of 12. On my reactant side, I already have 2 oxygens, so I need 10 more. And since oxygens come 2 at a time, I need 5 there. And what I like to do is go back and count up my oxygens at the end. I have 2 total in my first compound. I have 10 total there, and I can see that I have 12 total on my reactant side. I have 12 total on my product side. This is how I balance reactions. There are many other ways to do it. And yes, so there's a question. The first step is to put a 1 in front of the most complicated molecule. That's right. That's what I'm calling this first molecule. Would you ever put anything other than a 1 coefficient? Good question. Both good questions. So first off, I don't. But there are ways to do it that do put other numbers here. About the only other way to do it would be to put a 2 here, I think, and then balance it. I say that because when you do this, sometimes you will get a half coefficient here. And let me see if I can come up with one of those. Yes, so let me do a second one. This is going to be...
Professor, I have a question, Professor.
Yeah, go ahead.
Please, do you mind if you can go back and explain again what you did on 8 and 4 on the process?
For the hydrogen?
Yes. No, I think that was the oxygen. You say 8.
Oh, yes. So here, so when I count up my oxygens, right, because I want to get how many oxygens I have total, and then because then I have to make sure I have the same amount of oxygens on the reactant side. There's 4 for a coefficient, which means 4 CO2s. Each CO2 has 2 oxygens, so 4 times 2 is 8. And then here, there's only 1 oxygen in H2O, and we don't usually put the 1 there, but we can imagine a 1 there, and 4 times 1 is 4 more.
Okay, how do you come up with 5 on oxygen?
Good. Yeah, no, good question. Okay, so are you happy with the fact that I have 12 oxygens on the product side?
Yes.
Okay. Then I have 2 oxygens in this first compound because 1 times 2 is 2.
Oh, okay.
Okay. And then I need 10 more because then I will have 12, which will equal the 12 on the product side.
Okay, I got it. Thank you.
Yeah, sure. Good question. All right, I'm going to do another example in this problem because some of the examples when you work this homework question will come across this. So let's see. And then what you'll come across is you'll come across an answer that has a half coefficient in it. And let me show that to you. I think this is one. Let's give it a shot. Okay. So again, so even though it's only got 2 elements, and so do some of the products, my C2H6 has 8 atoms. So I'm going to call this the most complicated and put a 1 in front of it. Then I get 2 carbons, which means I need a 2 coefficient on the product side for carbon dioxide. Then I have 6 hydrogens, 1 times 6. Hydrogens come 2 at a time, so I need a 3 coefficient here. From there, I can see that I have 2 times 2, which is 4 oxygens, plus 3 times 1, which is 3, for a total of 7. I have no oxygens in my first compound, which means that I must get 7 with whatever number I put right here. If I put a 7 here, 7 times 2 would be 14, so I know the number is not 7. The number is actually 7 halves, or 3.5, however you do it. But 3.5 times 2 is 7, and 7 halves times 2 is 7 as well. But what you have to know is that whenever there's a fraction, the last step is to clear fractions, because balanced chemical reactions have whole numbers, not fractions in them. So my final answer for this one would be 2, so is to be to multiply the entire reaction's coefficients times 2. That's going to give me 2 C2H6 plus 7 halves times 2, or 3.5 times 2 just gives me 7. I get 2 times 2 is 4 carbon dioxides, and 2 times 3 is 6 H2Os. And so if this is your reaction, the numbers you are going to put into the Blackboard system would be 2, 7, 4, and 6, and that should get you the right answer. Any questions about that? That's what I meant by, and some methods would just say, well, if I think it's going to be an odd number, I can start with a 2 here. I don't know if Khan Academy or some of the other ones say that or not, but there are other ways to do it, and any way is fine as long as you're comfortable with it and it gets you the right answer.
Like the half number, right?
Say that again, please.
That means on this case, we just multiply the out number.
Oh, so we had a 3.5 here. And so in order to clear the fraction, you have to multiply all the coefficients times 2.
Okay.
Not just the 1 here. So we had a 1. We multiplied everything times 2 to get this final answer down here.
Why don't you multiply the C2 by 2?
Here, the C2?
Mm-hmm.
Good question. So the way that chemistry works is that these formulas cannot be changed. The only thing we can change to balance this are the coefficients in the front.
Okay, all right.
Yeah, and to say one more thing about that, so think of it this way. So we went through all this nomenclature to learn how to write good formulas. And so if you change the formula, you have an entirely different molecule with a different name, and then it wouldn't be the same reaction. So yeah, no, it's a good question. I think sort of our process for doing this is, and this will be throughout the entire course. So write good formulas for your reactants and products, and then use coefficients to balance it. Okay, sort of a two-step process.